All right, so the Linux file hierarchy structure defines the directory structure and directory contents in Unix-like operating systems. It is maintained by the Linux Foundation. / represents a root folder. All files and directories appear under the root directory, even if they are stored on different physical or even virtual devices. Only the root user has the right to write under this directory. So /bin, essential command binaries that need to be available in user mode. For example, cat, ls, cp, etc. /home, the user's home directories containing saved files, personal settings, and all that kind of stuff. /sbin, Linux commands located under this directory are used typically by system administrators for system maintenance purposes like rebooting, ifconfig, that kind of thing. /boot contains bootloader files. For example, grub files are located under /boot. /etc, and you may have heard /etc. This will contain configuration files required by all programs. For example, resolve.config. /lib. These are libraries essential for the binaries in /bin and /sbin. /dev. Essential device files, including terminal devices, USBs, or any device attached to the system. For example, /dev/null. /opt. This will contain optional application software packages. /proc contains information about system process and kernel. /mnt, temporary mount directory, where sysadmins can mount file systems. /var. It contains variable data like system logging files and temporary files. /media mounts points for removable media such as CD-ROMs and the like. /tmp contains temporary files created by system as well as users. /srv contains site-specific data served by this particular system, such as data and scripts for web servers. /user contains binaries, libraries, documentation, and source code for second-level programs. So here we are with our next title, System Management, and our second subtitle, which is Manage Files and Directories. So the first topic that we're going to cover in Manage Files and Directories is file editing. While file editing, we're going to be using some of these commands. Here's some new ones for you. So one of them is the sed command. The sed command in Unix stands for Stream Editor and can perform many functions on the file, such as searching, finding and replacing, adding, deleting. Although the most common use of the sed command in Unix is for substitution or find and replace. See, using sed, you can edit files without even opening them. So it's a much faster way to find and replace something in a file than to first open that file in a visual editor and then replace it. So here's the syntax of sed. Sed options, / open square bracket script, close square bracket, open square bracket input file, / close square bracket. Another useful command is awk. So this is a script language for manipulating data and generating reports. The awk command programming language requires no compilation and allows a user to use variables, numeric functions, string functions, and logical operators. So awk is a utility that allows a programmer to write small but effective programs in the form of expressions that describe patterns of text. Each line of a document can be searched for and actions to be taken when a match is found on a line that can be defined. awk is mostly used for pattern scanning and processing. It searches one or more files to see if they contain lines that match the specified patterns and then performs the associated actions. All right, so let's have a look at what else can we do with awk. So with the awk command, you can actually scan a file line by line, split each input line into fields, compare the input lines with the pattern, and perform operations on matching lines. But also, awk is a useful command for transform data files, produce formatted reports. And also, the awk command is suitable for programming constructs. Formatted lines are also suitable for use in arithmetic and string operations, as well as loops and conditions. So here's the syntax of awk. Awk options single tick selection underscore criteria. Then you put your action between curly braces, single tick, input dash file, right angle bracket, output dash file. And then we've got another command here, printf. So it's this command which is used to print data to the screen in a formatted way. It's also used in programming languages such as C and C++. So we've got it here in Linux to display the string, the number, or any other format identifier given with the terminal window. So I'll show you the syntax of printf. Printf square bracket dash v var, close square bracket, format, open square bracket, arguments, close square bracket. Now, have you heard of Nano? Well, Nano is a simple and user-friendly text editor. Unlike other command line editors, for example, Vim, it doesn't have any mode. It has an easy-to-use GUI, or graphical user interface. It allows users to interact directly with text, although it switches between modes, just like the Vim editor. So Nano is usually included by default in many Linux distributions. But if it's not installed, you can easily install it yourself just by using these commands. Just like we can install with sudo apt update, which is a command group, we can use the command group sudo apt install nano for Debian and Ubuntu, and yum install nano for CentOS and Fedora. So our other command line operator is VI. So the VI editor is an interactive text editor. You can use it to create and modify text files. It is also the only text editor you can use to edit certain system files without changing the permissions of the files. Now, the Vim editor is an enhanced version of the VI editor. And we're going to use the VI command when we click to use the VI editor to create, edit, or view files. Syntax of the VI command goes like this: VI, so this command runs the editor, or VI file name. If the file named file name exists, the first page of the file will be displayed. Now, if the file does not exist, an empty file and screen will be created in which you can enter text.